In this demonstration, I'll show you how to solve equations that contain sine. The first question reads, solve sine x is equal to half for x on the intervals -2 pi and 2 pi. First, I'd like you to keep in mind the cast rule. The cast rule tells us that sine is only positive here and here. So the angles that we have to find have to be either in the first or second quadrant because half is positive. If it were negative, then we would assume it's here or here. The next thing that we have to consider is which special triangle has 1 and 2 in it. The special triangle looks like this, where you have the angles pi over 2 as your 90 degree, you have pi over 3 which represents your 60 degree, and across from this is the square root of 3, and across from this is 2, and over here we have pi over 6, and across from that is 1. Now remember also that sine is opposite over hypotenuse. So you have two reference angles to work with. You have either this one or this one. The one that will give you 1 over 2 is the correct one. So let's pick this one for now. If we do opposite of this, we have the square root of 3, so it cannot be pi over 3. Let's try this one. Opposite is 1 and the hypotenuse is 2. So therefore, sine of pi over 6 would give us half. So pi over 6 is this angle, but we also need to find out this angle. And the way we do that is we take pi, which is half, minus pi over 6. That's how to find the angle that represents this larger one. So if we subtract these two numbers out, we find a common denominator. We will end up with 6 pi minus pi over 6, and that's 5 pi over 6. Now keep in mind something. Here it says they want intervals between -2 pi and 2 pi. These two are between 0 and 2 pi. So to find out from -2 pi, you're going to take this angle, pi over 6, and subtract it from 2 pi, and you're going to take this angle, 5 pi over 6, and subtract from 2 pi as well. And that will give you the other two angles that are between -2 pi and 0. So let's do that. Let's take this angle and subtract them, and this will resolve to the following. We're going to multiply the bottom and the top by 6, so we end up with 6 at the bottom, and at the top we have pi minus 12 pi, which is equal to 11 pi, and that's another angle. And over here, we'll multiply this by 6 and that by 6, so we have 5 minus 12, which is equal to -7 pi over 6. So I'm going to highlight every possible angle that represents this ratio. Let's move on to question number 2. In question number 2, we have more of the same, except now we have to solve for sine x. And the way we're going to do that is we're going to bring this number over first. So we have 20 sine 3x, and I've brought over that -2, which makes it 10 on the right side. Divide both sides by 20. On the right side, we end up with 1 over 2, and on the left side, we have sine 3x. Notice that our ratio is positive, and since our ratio is positive, the angle has to be here and here. Now, of course, the difference between this question and the previous one is that the intervals are between 0 and 2 pi, so it's less work for us. Now, which special triangle are we going to use? We're going to use the same one as above. Which of these two will be our reference angle? Well, given our experience from the top question, it should be pi over 6. So what we're going to do is take 3x and equate that to pi over 6. And also, 3x is equal to 5 pi over 6. And if you're confused as to why, all I did is take pi and subtract it from the following. Pi would be half a round minus what that is, and it will give you this angle. Now all we have to do is solve for x in both situations. So to solve for x, we're going to divide this side by 3 and this side by 3. And if I do that, on the top I end up with pi over 18, and at the bottom I end up with 5 pi over 18. And there you have it. That is how to solve equations containing sine using special triangles for their angles. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.